All right, before I do number 15, I just want to kind of go over some things about sine. um, your basic sine curve starts at the origin. All right, starts here and it goes up and it goes down and it goes back up again. It's starting at 0 and then it's ending at the 2 pi. The 2 pi, that is the period, because to make one full circle you'd have to go 360 degrees, and somehow they're taking the unit circle and converting it onto the x-axis, and this gives this sine wave. And the height of it, the standard height is always right at 1, and they call that the amplitude. And then if this thing shifts up or down, that's when you're adding the d to it. And if it shifts left or right, that's when you get something on the inside of the parentheses with the x, like it'll be x minus something. And that's what the next picture is showing. You've got the blue graph, the red graph, and I'll just have to use regular pens, I guess. You've got, this is the original sine curve, the blue one. But then you'll notice that the red one, it's still at the same height. These are all, let's see, these are all still at the same height. So the amplitude has not changed. But the red one has been shifted to the right. It's actually been shifted. It was right here, and now it's right there, which is halfway between 0 and pi over 2, which is 90 degrees. So this is a 45-degree shift, and 45 degrees is pi over 4. And so you can see on the red one, there it is. It's pi minus x minus a pi over 4. So it'll shift 45 degrees to the right. Now the green one gets even crazier because it was right here and now it's starting there. So when you go up and you go down and you go up, you're going from pi to 3 pi. That is a period of 2 pi. It's just that, you know, when you start a sine wave, it starts down and goes up, goes down and comes back up again, and it usually starts right there at the origin. This one has been shifted 90 degrees because it went like this from 0 to pi. So you can see they put it right there. It's x minus pi. That's shifting. And then let's see, then they talk about the midline. Well, that involves when the sine wave either rises up or goes down. And you can see that instead of being here, it's up right there. This is where D would be located, whatever D is. So if this says a sine of x plus 5, then that's 5. And now your midline, which is the red line, that's the line that the curve goes up and then intersects it, goes below it, comes back up, intersects it, goes up and comes back down and touches it. And these are all the exact same shapes. This hill and that hill, they all match. So they're midway. It's right in the middle. They call it the midline. Now, if the curve itself gets stretchy, then you're messing with the amplitude now, and that's going to be the number in front, which you can see they've got a 3 here. So instead of the sine wave starting here and going up to 1, and then let's see, how's this? Okay, they've got it like that. Okay, so it would go womp, womp, womp. That would be the original sine curve. You can see that this blue graph starts here, goes up 1, 2, 3. It's going up 3. and then it comes back down 3, goes down 3, comes back up 3, goes up 3, goes down 3, goes down 3, goes up 3. I didn't mean to do the whole thing. Sorry. Sorry. Come on, get off of there. It goes up, and then it goes down and back up again. That is one full sine wave, and that's going from 0, here's 0, to pi. So the period is actually half of a 2 pi, which is a 1 pi. But the amplitude has gone up to 3. So instead of just x, they've got 2x in there. And then it went up by 1. It rose up by 1 because it went from here up to there. All of these are 1 above the x-axis. And that is your, that's when it shifts vertically. So when you come down to number 15 and you're looking at it, it's supposed to be, your answer is supposed to be in the a times sine parentheses bx minus c plus d form. And when I look at this, it is starting at 0 on the x-axis, but it's at 2 on the y. So this thing has gone up 2 units. It has shifted plus 2. However, when you look at the graph itself, it goes only from 2 to 3, then comes back down 1, back up 1. The amplitude right here is still just a 1. And then because it's starting technically on the x-axis at 0 right here, it goes a full 2 pi. That whole yellow curve that I've highlighted goes from 0 to 2 pi. That's the regular standard period. So it's not doing anything in here. It's just going to be the x. So my answer should be f of x equals invisible 1 sine of x plus 2. Because really the only thing that has changed on this compared to the original sine function, which if I drew the original sine function in red, it would go up and come down and go back up again. The only thing that's happened is that red graph has shifted up 2 units. If I highlight in between, let me make a bigger one. In between here, between the red and the blue, that is a shift of 2. So I already put it into Mobius to show you. It's sine of x plus 2. And make sure you put the parentheses around the x because that's what it says. Enclose the arguments of the function in parentheses. It'll count it wrong if the parentheses are not around your x.